Hi, ladies and gents. My name's Simon Timpley from the International Food Safety and Quality Network. Welcome to edition 90 of the Food Safety Fridays webinar program. Today we have Robert Rogers from Mettler Toledo, and I'll be introducing you to Robert shortly. But just first to say, today's webinar is being recorded. If you miss a bit or you have some technical problems, don't worry. It's being recorded and we'll send you the slides, the certificate of attendance and recording later by email, so you'll get that. And also to say that this webinar program is kindly sponsored by Mettler Toledo, Trace Analytics, AIB International, DNV, GLB Business Assurance, and Safe Food 360. So those kind organizations help to support this and bring you some free education regularly. Okay, I think that's it for now. At this point, I'd like to introduce you to Robert. I think most of you have met Robert previously. Are you there, Robert? You switch your webcam on.
There we go.
Yo, how are you doing, Robert?
I'm doing well. How are you today, Simon?
I'm very good. And you're in sunny Florida?
Yes, I'm working out of my home office today in Tampa, Florida. Looking forward to, we're moving into our brand new 265,000 square foot facility just down the road from my house. So I'm looking forward to that in the next few weeks.
Wow, that's fantastic.
Yeah.
Not much traveling. Very good. Okay, if you could get your presentation ready, Robert.
Sure
I'll
thing.
just let the audience know about next week quickly. Next week we've got Kim Onett from NSF International, Food Safety Culture, Meeting Audit Requirements. So that should be a useful topic. So if you want to click the register now button, it'll open a new window where you can enter your email, name and email and register directly, or just follow up with the emails that we do send over the next week. So we've got 186 online. Yep, you're already saying hello in the sidebar. Greg from Pittsburgh, hey, Zed, that's Steve. Constantine from Russia. I think Constantine's a regular. See her quite regularly. I can't see your name. Xion Fang from Salt Lake City. You're all very welcome anyway. So get to know each other in the sidebar. Do type your questions and comments throughout. And if they're not answered by the learned attendees, then Robert will pick those up later. Is your presentation ready, Robert?
Ready to go.
Yeah, feel free to share it, no problem. And then I'll be back for the Q&A later. Okay.
Sounds good. Appreciate it. Well, I'd like to thank everybody for joining us on this Happy Food Safety Friday. Looking forward to spending a little bit of time with you. My name again is Robert Rogers. I'm the Senior Advisor for Food Safety and Regulation with Mettler Toledo. Mettler Toledo is quite the diverse organization with several different divisions, laboratory division, a retail division, industrial division, mainly known for our precision weighing instruments. I'm part of our product inspection division, which takes care of the metal detection, X-ray inspection systems, inline check weighing systems, and vision systems. And typically my presentations are kind of focused around either understanding the technology and how to utilize it and implement it within your processes, or related to utilizing those solutions to meet the needs of various regulatory or various compliance needs that there may be out there from a food safety perspective. Today I'm taking a little bit of a different twist. Oftentimes our systems are required to be utilized in the scheme of food safety and ensuring that products are within compliance and within specs so that they can be safely enter into the marketplace. But oftentimes our equipment actually, it creates a lot of waste. Pretty much anytime one of my systems activates, it's rejecting a non-conforming product from the line, and that non-conforming product certainly has had some value added to it as it traveled along its value chain. So today we're going to look at really looking at how to reduce waste and improve efficiencies, particularly in line with product inspection devices. Well, we hear terms like lean manufacturing and different processes that go along, and certainly we have a lot of rigorous food safety standards in place, and oftentimes it may seem that those are incompatible. The former is about simplifying the process and eliminating unnecessary waste, and the latter could be seen as adding cost and complexity and resources into that. The truth is that combining both lean manufacturing and rigorous food safety standards, it forces the business to adopt a company-wide approach that, not only improves efficiencies, but equally protects profits, the end consumer safety. It's why many facilities are looking at closely where to reduce waste and improve things like OEE, or overall equipment efficiencies or effectiveness. A survey by the Harris Research showed that more than half of consumers would switch brands in the event of a product recall. From that, 1 in 5 said they would avoid any product associated with that brand. Lack of safety issues can be very expensive. So as we look at trying to find solutions to make products more safe, those can always be seen as added value. Certainly, if a scandal were to break involving a product, the brand would be worth less than it was the day before the news broke. Consumers do pay for reputation, for brands that they trust. Anything you can do to improve safety is adding value. In the context of lean manufacturing, it means that any time and effort that you put into food safety and due diligence, really in the big scheme of things, is never wasted. We see the increase of standards such as the ones that are approved under the GFSI schemes, such as BRC, SQF, IFS. Those are certainly helping manufacturers to provide reassurances that the products that are coming off the lines that they're producing are in fact safe for consumption. And again, product inspection systems like metal detection, X-ray systems, vision systems, and check weighing systems, they help companies to achieve compliance with global safety standards and regulations, but only if the equipment is installed right, operated properly, maintained correctly, and certainly if there are good programs and processes that are built around the technology. Whatever you want to call it, lean manufacturing, lean thinking, lean production, the essence of lean is cutting out any expenditure of time, effort, funds, or resources that doesn't add or maintain to the brand or protect product value. In this context, value is really any aspect of the brand or the product that a customer is prepared to pay for. Effort that you apply to anything that doesn't add value, can be viewed as wasted effort. Historically, in product inspection systems have been seen at the end of the line of the process. Certainly it makes sense when we're checking for things like the packaging label to make sure that it's the proper label, has a readable date code and expiration codes on there, that any of the important critical information regarding the label is in fact present, the proper declaration of allergens and so on and so forth. We have to wait till it's in its final package to really do that inspection. Check weighing, a lot of times similar to where the package is in its final package, it's in its final weight. We have to verify the weight is correct on that package once it's in that final package is going to be presented on the store shelf. And certainly for metal detection and X-ray, it's made sense to do that end of the line inspection because the risks of further contamination from a foreign material are greatly reduced as it is in its final protective package. But the reality is at that point in the process, if we do discover an issue, pretty much we're throwing away everything. We're throwing away all the raw materials that it took to manufacture that product. We're throwing away the packaging that it took to make that product appealing for the store shelf. We're everything that we've added into that product at that point. Now that there is an issue with that product, we're going to throw it away and potentially have that occur as waste. So when you look at it from a perspective of efficiency and waste generation, you may have a different view as to whether if that is the right location to have these sort of inspection devices. Another thing to consider would be the time required to investigate the non-conforming issue itself. Regulation, many food safety programs have, as part of the program, when we identify a non-conforming issue, we have to go through a root cause analysis and corrective action plan. So to understand how that non-conforming product got to this point, how we can prevent that non-conforming product from happening again, whether it's a contamination or a mislabel or an underweight, overweight type situation, doesn't really matter. But at that point in the process, at the end of the line, we're looking back through the entire value chain to try to discover where that issue occurred. Can be very challenging, very time consuming, very resource intensive. So at that point in the process, maybe that's not the best or only point in the process where we should be performing inspections. So here on the screen, we kind of have the typical plant layout. You have a little bit of a receiving area where we're getting different materials receiving into the facility. You may have a batching area where you're scaling out some of those larger bulk received products into smaller batches for production. Then you may have some sort of mixing or blending or grinding stage within the process into some sort of further processing, whether it's cooking or freezing or whatever the course may be, and then into the final packaging and off to the shipping docks to be sent out to the consumers. Basically, at each stage of that process, you're continuing to add value into that product through time, materials, resources. And again, if we discover the issue at the end of the process, all of that could be considered as waste. Metal detection, again, as an example, contamination induced at any point in the line can have a huge cumulative effect as it travels downstream. Every process of the step, costs of waste of the product rises as you add more value into the work in progress. Metal detection, if we had a contamination that was brought in from the raw materials and then we begin to send it through our process, the mixing and grinding stage, not only could it make that contamination smaller and more challenging to detect, but it also could spread that contamination over a wider berth of that product, as well as the potential dangers of damaging the actual processing equipment, which in turn creates more contamination. So all the way down the line, there are dangers that metal shard would cause damage, again, to the processing equipment, inducing more contamination. In reality, the best way to avoid waste, as far as that's concerned, is to prevent the contamination from entering the line in the first place, ensuring we have good supplier programs in place and that we're challenging those suppliers to ensure that the products they're supplying the facility are in fact safe for production and are of the value that you're paying for. Product handling is another location where we can see a lot of waste occur. Throughout that process of that facility, as we're transitioning from one department to another, from one conveyor system to another, there is the potential for spillage, transitioning from conveyor belt to conveyor belt. So it's important that when you look at the overall design of the system itself, that we're also taking those sort of things into consideration for, reducing waste and ensuring that things aren't able to spill off there. So transition points can be tailored to suit specific applications to ensure that product's not lost. Multi-lane rejection systems for bulk flow applications, where rather than rejecting the entire width of the belt, we're only going to have to reject the small portion of the belt that has the contaminated product within it. Having system capabilities such as fail-safe systems. Obviously, if we had an incident, where something was supposed to be rejected off of the system via an air pressure device, whether it was a pusher or an air blast, doesn't really matter. And for some reason, there was a problem with the air pressure, and we were unaware of it. Now that non-conforming product was able to make it through the system and pass down the line and end up as a customer complaint, and, heaven forbid, a product recall become necessary, and then all of the product that we manufactured within that particular time frame, becomes product waste as we have to recall it and dispose of it. So fail-safe systems such as air fail systems, reject bin full systems, reject confirmation systems, those sort of devices will help to provide confidence that that system is functioning at all times. So those sort of design issues can also play a role in the efficiency side of things. The more confidence you have in the system, the less likely it is for you to have to spend resources and time to interact with that system, whether it's a product changeover or fixing a fault condition or whatever it may be. So it's not really just the equipment and how it's designed and where we apply it within the facility. It's also the processes that are implemented and the setup the equipment utilized. Those should all have some considerations when we look for efficiencies and reducing waste. For an example, meeting the requirements for weights and measures. The inline check weighing capability ensures that 100% of the products have been inspected as they go across that weigh cell, as opposed to a random sampling. You can imagine pretty much whether it's a metal detector where we're challenging it every so often with physical contamination, the test is only as successful as the last successful test. So any products, if we discover, if we go up and perform a verification activity on a system and we discover that there is an issue, all of the products since the last successful verification really needs to be addressed. When we have 100% check weighing, where we're checking 100% of the products, certainly we can look back and identify a smaller amount of product that needs to be dealt with when we find these issues that occur, as opposed to random sampling maybe twice a day. With an inline checkware as well, you could have, because we're sampling 100% of the product weight, you could also have feedback controls to things like filler stations to automatically adjust and correct the issue at the filling station. Again, reducing the need for human interaction with the system to understand that there's a problem and then go take and correct the problem. You can have an inline system where that feedback is occurring automatically, again, reducing the time that we have to send somebody over there, improving the efficiencies of the overall line operation, and just have everything ensure that it's being done correctly. So here's a little bit of an example of a case study that we looked at, where a slight improvement in weight measurement capabilities had a major impact on annual savings as well as packages produced. In this facility, they were basically overfilling the package by 1 gram in order to limit customer complaints for an underfilled product. It may not sound like much, but when you look at the potential savings, in this case, the nominal value was 460 grams. The material cost, a very nominal cost of only 1 cent a gram, with throughput pack of 200 packs per minute. Basically, when we look all down there and they reduced that 1 gram overfill, it equated to over $31,000 of annual savings. And that's not, I guess, what really impressed me the most. What really impressed me the most was the additional 60,000 further products that they could have produced, and as well as the material saved. So when you look at what a gram's worth, in this case, it can be significant. So having an inline system where we have that automatic manual fill station feedback, 100% of the products are being looked at. We don't necessarily have to just go with the overfill mindset to ensure that we're protecting the brand, the consumer, and the consumer satisfaction. So when we look at some of the other technologies, metal detection and X-ray systems, it may sound like a good idea. I mean, these devices are designed and implemented to detect the smallest contamination possible. And so you might see that setting up a metal detection or an X-ray system to be more sensitive and detect the smaller contamination to be a positive step. However, if the increased sensitivity results in an increase of falsely rejected product, that's going to equate to a lot of product waste. Frequent false rejects also can create a loss of confidence in the system. If you have a line operator that's standing next to a metal detector that's going off all the time, that then becomes the normal day in, day out operation. That's what they're used to. That silly detector's always going off. Every time we investigate to try to find the contamination in the rejected product, we can't find anything. So we know that it's a false reject. So I've seen it to where we'll have employees that if the reject product is in an unsecure reject bin, where they will have access to that product and maybe remove that product and place it back on the line just simply because they don't believe that it is in fact contaminated. So that's not only going to increase the risk for contamination meeting the end customer, but it's also going to potentially increase the amount of time and effort that we're putting into that system, and the overall efficiencies of the production line. Now the operator is going to go over there and they're going to adjust the sensitivity more frequently. They're going to maybe have to perform verification checks with the test samples more frequently to help increase their confidence in the system. Again, I'll talk a little bit about some of the fail-safe capabilities, like what we call condition monitoring, where we're going to monitor critical areas of the detector at all times, and then alert the user when we notice a trend of a change in those critical monitored settings, rather than a fault indicator. When you have a fault indicator, you're going to go from a working state to a fault state. There's no in-between time to actually address the issue prior to the fault shutting down the line, versus having a condition monitoring type capability where we're always monitoring the condition of the system. And in turn, if we start to recognize that things are starting to fall outside of tolerance, that then we can, before it goes into a fault condition, pre-plan times to interact with the system and correct that issue, such as during the next downtime of the line. I'm sorry if you hear a little bit of background noise. As I mentioned, I'm at my home office today, and I guess the mowers just went by, so I hope it's not too bad. So here's another little bit of a case study that we have. In this case, we're looking at testing of the metal detector. Currently, the facility is testing every 2 hours. I would say in my 22 plus years with Mettler Toledo that's probably about industry average. People are testing it every hour to every 2 hours. That's probably about the industry average. In this case, the test takes 3 minutes to perform. and they're performing it 12 times a day on 24 different lines. So you can see that there's about 864 minutes worth of lost production that is occurring. When we look at the bag production rate versus that lost production time, it's 86,000 bags. Do that over the course of 350 working days, let's say a year, and that's 30 million bags of lost production, and that's simply just from performing the normal required verification type activity on a typical metal detector. Whereas if I look at when we test the detector, and in all actuality, I prefer to use the term challenge the detector. When I challenge the detector, the only reason I'm really doing it is to ensure that it's operating correctly and functioning properly. If I had the ability to have a higher confidence level in the operation of the system, I could justify maybe a less frequent verification timing. So in this case, rather than testing every 2 hours, because I don't have a whole lot of confidence in my system, I have a lot of false reject activity, I'm always having to interact with the system, adjusting things up and down, so I don't have a whole lot of confidence in that system. Yes, I'm going to test it every 2 hours. But if I can build confidence in the system where I don't have a frequent false reject issue, I'm not having to adjust sensitivities on the detector every day, I've gone through a very stringent validation of the system, so I have a true understanding of the capabilities of the system, I have a lot of confidence in that line. I'm only going to test it every 12 hours now. And in this case, you can see the significant savings to where testing every 2 hours versus testing every 12 hours, not only in the production loss and the products loss, but add those to increasing basically 25 million additional packs per year and saving 175 man days annually just by simply going from an every 2 hour test to an every 12-hour test. Now, I understand a lot of people have their food safety programs in place, and it's maybe written in there that we're supposed to test it every 2 hours, and certainly you should be following your food safety plans as written, no doubt about it. But as you begin to collect data over time and analyze the data of the system, let's look at some of these things. Let's look at the potential of reducing the time required to perform things like testing. Find ways to build confidence in your programs and your systems that don't require you to have to interact with them and lose significant amount of productions. Again, we understand that they're going to be required by regulators, by food safety plans, by your internal plans, by your customer demands, no doubt about it. But there are ways where you can look to find little savings that over time can add up to be very, very significant savings. So we talked a little bit about in the beginning about OEE and overall equipment effectiveness or efficiencies, either one. I've heard it called many different things. The reality is a lot of the requirements for things like food safety and various regulatory requirements are going to add some cost. They are going to, certainly add cost to the overall program, whether it's within time or resources or money itself. But really, in today's world, there's no room for complacency in the highly competitive food arena that we have today. Really, no matter how safe the production line is, you have to stay focused on continuous improvement. Reality is because that's what your competitors are doing. Every piece of equipment, every operation on a production line, it really does have the potential to reduce those overall efficiencies. And the more complex the line is, the more opportunities there are for equipment failure, the more opportunities there are for human error, the more difficult it is to make quick and trouble-free changeovers from one product to another. So having, again, some of the capabilities built into today's technology for routine performance monitoring, we have a function called PVR, performance verification option, where you program how frequently you want to challenge or test that system. It alerts the user when the test is due. It records the results of that test through the data collection capabilities. That tied into, again, a system that has condition monitoring as opposed to a fault monitoring type system. Having that combined with automatic data collection capabilities really are ways where we can streamline that process and find ways to improve efficiencies rather than having to handwrite all this record retention information and the collection of the test results, having to store that in an offline system somewhere where it's more challenging to receive or retrieve. If you have the capability of automatically sending data to a data collection source, that data is going to be more easily retrieved. I hear a lot about data collection and people wanting to go towards automatic data collection and reporting capabilities, and that's certainly the trend in the marketplace. But I do want to kind of just state, don't just collect the data. Go over the data, read the data, understand the data, learn from the data, make informed decisions about your production based on that data. Data is a fantastic thing as long as we utilize it. And I think far too often many people are just simply collecting the data for the record retention capabilities to meet the requirements of outside auditors and such, and not fully utilizing the value of the data to understand how to improve their process. Again, your competitors are going to be doing that. We should be doing that as well to ensure that we're staying ahead of the marketplace, learning everything we can. Whatever I learn today, I can implement a change tomorrow that can improve my process. And that continuous improvement mindset is really how a lot of organizations are beginning to work today. So again, that accurate production data is really at the heart of OEE. If the performance data is faulty or incomplete, well, you'll be misinformed, looking for improvements in the wrong places, and quite frankly, you could actually be making things worse. Here's a little bit of a chart that kind of shows an OEE calculation chart, and we can see that we've got some, we have the total available production possible, and then we have some planned downtime, things like your breaks and meals, planned maintenance and cleaning schedules. All those are certainly taking away from the overall equipment efficiencies. And that's why we see that the 100% OEE begins kind of after all those planned sequences as far as normal breaks and things like that. Then we have the planned production area, where now we're going to start taking away from that OEE. I mean, we have no choice. In fact, most OEEs we look at globally from a world-class OEE is about an 85% OEE. So 100% is really never going to be fully attainable, because we do have things that happen during production, like product changeover. We have to perform these verification tests ever so frequently, equipment breakdowns, things of that nature. Then we come into some of the performance loss, quality loss, and you see as we go along, everything is kind of taking away from that OEE. really manual data collection makes looking at these sort of things more challenging. The process is labor intensive. In reality, it's kind of guaranteed to be inaccurate no matter how well trained the team may be. You can't expect busy operators to log downtime accurately. When the line stops, the pressure's on to get it running again. Not to reach for the stopwatch and the pen and start to manually collect the data. And then you have the human factor involved. No two people are going to record events in the exact same way. It makes data inconsistent and untrustworthy. Data collection manually it's too slow. Between the event and the presentation of the data, there could be days of delay, several stages of transcription and consolidation, every step introducing an opportunity for error or really judicious editing. I've seen that along the times as well. To be reliable, production performance data should be collected digitally and automatically in a consistent format that really everyone understands and trusts. So here we can see some of those areas that we've talked a little bit about. If we can reduce some of those factors, the impact that it has on OEE and significant gains. So utilizing the right product inspection solutions in the right locations, having them designed and built to increase your confidence in their ability to function as intended can have significant improvements in OEE. When utilized as part of a company-wide approach to product safety, inline product inspection solutions is really an essential item in the mission to protect consumers and brand reputation. I don't know of many facilities today that don't have some sort of foreign body detection device in there, whether it's screening or magnets or metal detection or x-ray systems. We understand the risks today. We understand that there are technologies out there that can help to reduce the risks, and using those are certainly a good step in ensuring that not only are the products safe, but they're of good quality as well. But like all technologies, inline inspection systems have their limitations as well. It's really a matter of understanding the limitations more than the capabilities. So again, that you can make informed decisions on to whether that's good enough or not. To achieve continuous improvement, production line managers have to attack OEE from every angle. The right inline inspection systems can help. Certainly having systems with sophisticated onboard analytical tools that provide real-time data connected directly to data collection systems, so at any moment in time, managers can see how their line is performing. They have data right at their fingertips that invites them to delve deeper, to see where they can make the critical changes to raise their OEE over, to that closer to that target of 85%. The latest product inspection solutions are employing imaginative technologies and sophisticated analytical tools to help improve OEE, reduce testing capabilities, automatic testing capabilities are some of the features that our latest systems has had. The automatic testing capability is great because you can even perform that remotely. So if we had a system that was on a mezzanine, rather than having an operator have to climb up to the top of the mezzanine to perform the test, they can perform the test remotely. So not only is it more efficient, but it also has an aspect of worker safety improvements. So there's a lot of things that you can look at with your product inspection solutions to ensure that you're utilizing them in the best way so that they're not contributing to inefficiencies and the creation of waste within the production environment. So ensuring that we have stable systems, and I always like to say that successfully inspect production with minimal false rejects, deployed in the right locations, that are managed properly, we can certainly find ways to reduce that unwanted waste, improve OEE, increase our confidence in the systems and in our safety programs, and that's what we should strive to do day in and day out. And that is my last slide, Simon. So I'm happy to have a discussion now.
Okay, Robert, if you can stop sharing your slides, we'll come back on webcam, and then we'll do the Q&A. Thanks very much for that. Yes, there have been some questions. I don't know if you've seen them coming into cyber. Antonio, will testing of the MDs every 4 to 8 or even 12 hours be acceptable by, well, the certification body SQF? Can you turn your mic on? Sorry, I think you might have switched it off.
Can you hear me now?
Yes, can do.
Sorry, clipped the mute button. I hope the mower wasn't too bad of a problem for everybody. He kept going back and forth, so I tried to cut him out when I could, so I do apologize for that.
No, it's fine. It's fine.
So in regards to testing the metal detector, most standards, whether it's FSMA, whether it's SQF, BRC, most standards don't really specify a time frame for verification activities such as testing the metal detector. What they're going to do is they're going to ensure that whatever you have written within your food safety program, you're actually working towards. So if you have it in there that you're testing every 2 hours, you better have some proof that you've been testing it every 2 hours. So it's really up to the facility. Now, most facilities make that determination on what happens if things go wrong. If I test it at 8 o'clock in the morning and I don't test it again until 8 o'clock at night, and it doesn't work at 8 o'clock at night, all that production I ran during that day is really, it needs to be quarantined, maybe reworked, is suspect for contamination because we don't know when it failed. So there is that to take into consideration. But you know, again, I kind of look at testing of systems. The only reason I want to test the detector is because I don't believe it's functioning correctly. So if you can develop higher levels of confidence in its operation, that means ensuring that it is properly and diligently validated. So we understand what its true capabilities are, that we we set them up to successfully run production and understand what their capabilities are, as opposed to setting them up to detect a spec and living with activity like false rejects. The more confidence you can have in that system, I would assume the less frequent you need to test that. And that can be something that's looked at over time. I mean, if we've got a company that's testing it every 2 hours, certainly in the course of a time frame of about 3 months, you should have a lot of data as to, is it working correctly? Do we get the same results every time? Is the signal strength the same for the ferrous metal as it is, day in and day out? Those are a lot of the data points within the system that you can look at to provide confidence, and then to maybe, revamp the plan and remodernize the plan so that it really works best for you. Certainly, we want to be safe. We want to ensure that we're not, doing things outside of the scope of what's acceptable within your required plans and things like that. But those are some of the things that you can look at as ways to reduce waste and, again, improve those efficiencies of the operation.
Yeah, and as you say, decisions should be based on data.
Absolutely.
Okay, Frank. He's asking the audience actually, but maybe you can say how many have a lock box on their metal detection collection container. Is that a good idea to have that? Yeah,
and so I look at a lot of things, and I am fortunate enough in my career to get to experience a lot of different facilities and see how they actually utilize the technology in their operations. We sell a lot of systems that have secure lockable reject bins. Oftentimes when I go out in the field, though, I hear discussions about, well, if it's lockable now, if I need to get into that box, I got to go get somebody, they got to get the key, they got to do this, that, and a lot of times you'll see those protections of the systems violated during normal production because it's easier. It's easier to have the bin open and to get in there. I like to look, as I've gone further and further in my career, I get closer to the root cause analysis of things. So what is the true root cause of that item ending up in the reject bin, or the need for the operator to go in there more and more frequently? Those are some of the areas you want to look at. My feeling is that if a product gets rejected off of a line, it should be seen as a non-conforming product. Anybody from that point on that interacts with that product needs to be properly trained and authorized to do so. That's why we're starting to see, I think, more sales of lockable reject bins and things like that, because that's the way standards are being written. Non-conforming product must be accessible only to authorized personnel. So that's a way of controlling that access. But understand how production works, and that, many of these manufacturing facilities, getting product out the door is a very, very high priority for them. And if something delays that process or makes it less efficient, it may not be something that they want to utilize. But look at the root cause. Why do we have to go in there so frequently? We shouldn't have to. My goal of installing any system, regardless of what it is in a production environment, is that it never goes off. That means 100% of the products you produce and put across that inspection device were good, and we're able to successfully make it out to the end customer. That should be the goal. If you have a lot of issues, whether they're rejects or false rejects, those are issues. Those should be dealt with. They shouldn't be happening. We should find ways to correct those and prevent those. That's how standards and regulations are written today, and we need to do that.
Yeah. So rejects are feedback to the continuous improvement of the process, aren't they? Yeah. Okay. Yep. Right. Sanusi, what is the minimum percentage of waste acceptable?
That's tough, and it's certainly something from many different areas and aspects of the food industry that needs some serious attention. I'm not sure what the statistics are by the year 2020, but I know we got about 7.6 billion people on the planet today, and trying to feed them is becoming more and more challenging, and it can be a concern. So when you talk about waste, I think that's probably one area where there's the biggest waste, is once it ends up in the consumer's hand and what they do with it, whether it's just simply throwing it away because they didn't get to it before it spoiled, or, certainly here in the States, you go to any of the restaurants and the portion sizes are extremely large, so that there ends up being a lot of waste from that perspective. In a manufacturing environment, in reality, I look at zero waste as being the overall goal. Some of the large manufacturers out there have plans for reducing waste over a certain percentage of time over the course of the next maybe 10 years or so. So it's certainly something that companies are looking at. From a perspective of the food safety and different regulations that have come up around there, you really have to be able to account for everything. So if you're bringing a certain tonnage of raw materials into the facility, you need to account for that tonnage. Some of that will end up in waste. Certainly some of that will end up as the end product. But that traceability and that level of traceability is really what is expected in today's world. And quite frankly, it's what's needed in today's world as we try to streamline activities when something bad does occur, and try to rapidly identify the exact products that are in concern, and minimize the amount of impact on the overall industry. So it's hard for me to say, hey, 10% product waste in a manufacturing is okay. I don't know what that number is. The goal, I think, should be zero.
Okay, cool. Yusuf, bit of feedback there. Great presentation. We use Metler Toledo for our annual calibration. Great company. There you go.
Thank you, sir.
Constantine, what are you saying, Constantine? False rejects are usually caused by not stable product process. Decreasing sensitivity is not the answer. It's improving product process stability, isn't it?
Yeah, I mean, to a certain degree, I would agree with that. There are times when I run into situations where the system is just set up incorrectly for the product, and that's kind of what I'm speaking of, more along the lines of false rejects. If we have a lot of diversity that is acceptable within the product, maybe that's a temperature variation or a moisture percent variation, that still is an acceptable product, we really need to set the systems up to accept that variation. If it's a good product to the facility, it should be a good product as it's being inspected by the inspection device. But if you're finding that, and that's where I say, sometimes people try to trace or chase the spec. I've got to hit 1 millimeter or whatever the number is. Well, if your system isn't designed and in the right location and capable of doing that, you're going to be chasing that number and maybe running up sensitivities to try to hit that particular spec, and in turn creating a higher level of false rejects. Ideally, if the product is out of scope and the detector for some reason has identified that because it's started to create a false reject, well, maybe that can help be a trigger flag to say, hey, we need to go look at the freezer temperature because it's not being frozen solid, or whatever the case may be. But it's a matter of, and I've said this time and time again in the various presentations I do, don't set up a system to see a spec. Set up a system to successfully inspect the production. Once you've done that, you can then challenge the system to see what it's able to see. If you set it up to see a spec, then you may have to deal with how it actually runs during production. So I would much rather understand the true capabilities of the system when it's set up to successfully inspect my production, and then make the determination as to whether it's going to be good enough or not.
Okay, very good. Frank, is it okay to set the test sphere on top of the item, or should it be within?
So when we look at things like test sample placement, typically that's either within metal detection or X-ray talk. With metal detector, it doesn't really matter in relationship to the product itself. What matters is the sample's relationship to the detector opening. The center of the detector opening is going to be the weakest place for detection. So if that means placing it inside of the package so that the sample travels through the absolute center of the detector, you would want to put it inside. If the package level is lower than the center area of the detector, then yes, putting it on top of that package places that sample as close to the detector center as possible. And that's where you want to run that sample. You want to, again, I don't like the word testing. I like to say the word challenging. I'm challenging the detector to detect the smallest contamination in the most difficult location to do so, and I'm ensuring not only the detection, but also the successful rejection of that item when the detection occurs as a complete test.
Okay, thanks. Juan, I think he's just saying, can foreign material systems help us with OEE improvement?
Sure. If you look at it from a perspective of, if you didn't have a contamination inspection system and a non-conforming product made it out to the marketplace and a product recall had occurred, so there's a huge potential for waste as that product gets recalled and disposed of, as well as damage to the brand. I don't think you're going to find any standard out there that requires a particular food safety inspection device such as metal detection or X-ray inspection. I mean, it comes with contamination. You have to go through the right process. Understand what the potential risks are. Find a way to prevent or eliminate those risks. And that's kind of, I find it hard to understand facilities that don't have inspection systems in place and their justification as to why they don't believe they do, especially when they have a grinder stage or they don't have a good supplier approval process in place. the risks for foreign material especially are everywhere within the production environment. I'm now beginning to see new factories built where production, there aren't any exposed product areas. All the product conveyor belts are covered to prevent anything from the factory environment falling and making its way into the product. Good inspection and maintenance programs on equipment to ensure that it's not breaking down. Things like that is what we're seeing. So you're not going to find anybody that necessarily says that you have to have these sort of things in place, but I think oftentimes a risk assessment and a thorough risk assessment really identifies the need for some sort of mitigating risk against a foreign material.
Right. It's a bit of a long one. I will read it because people on YouTube won't be able to see the sidebar. Paul, I recently investigated a customer complaint concerning product contamination with hard glass. I found out that the pieces of glass which the customer claimed were found in the product could be detected by our metal detectors. All control measures, including metal detector tests, were taken during the production. How would you handle such a complaint?
Well, one, the metal detector and detection of glass typically isn't the case. So that glass may have had some sort of lining on it or some sort of material within it that made it conductive, which is why if it was able to be detected by the metal detector, why it would be detected. Certainly we do have glass inspection within X-ray detection capabilities, and that's often where we see people that have concerns with glass as a potential hazard, utilizing X-ray to help identify if there is in fact a glass component within the package. But as far as that's concerned, I mean, when you look at having all these processes and programs and devices in place to help prevent contamination, certainly there are things, nothing is 100% foolproof. There are things that are going to happen that it's smaller than what the system's able to detect. That's certainly a possibility. The product was properly inspected and in fact detected, but for some way it made it back to the production line. Again, maybe an unsecure reject area that allowed access to that package and somebody accidentally misplaced it back on the line. There are any number of possibilities, but when it comes down to a customer complaint and how you provide justification as to your due diligence in preventing that contamination, that's why it's so critical that we are collecting data, that we have good validation studies in place, that we do and perform these ongoing verification activities. Those are your supporting documents and information to help justify that, hey, you did everything you could. If you can determine where that glass came from, that glass may not even be found in the manufacturing facility and it came in during transport or at the retail marketplace. There are many areas where contamination could be introduced along the production line, including the end consumer's kitchen as they get it into their kitchen. So it's very crucial that manufacturers today keep very detailed records of their programs, constantly review that information, look for ways to improve that on a daily basis, not only when we discover a problem, find ways to correct it and prevent it in the future, but also just, looking at that data every day and determining, have we done everything we said we're doing within our food safety plan and program, and then reviewing the food safety plan and program frequently enough to understand, is there ways that we can make improvements in there as well to do better? I think that's the mindset in the way that regulations and standards have been written today. All of them have a root cause analysis and corrective action and preventive action clause written within their guidelines, and that's what's expected. And hopefully someday you get to the confidence level that, hey, we've gone through all these struggles, we've eliminated glass, there's no chance of further contamination for that, and that's, someday you may get there, someday we may not. Fortunately for me, I think the world of that I live in the physical world, the physical contamination, that's a possibility. There's other challenges in the safety related field of food safety, like the microbiological issues. Those where some of the real challenges are, where different strains of different biological contaminations, they evolve and change over time. That's going to be a problem that I think we're always going to have to deal with. I mean, if you look back 15 years ago, you probably wouldn't think that spinach and cantaloupe would harm people, but today we know that they can. But I think that foreign material is one of those areas where you can have very good preventive measures in place, not allowing these items into the facility, have very good supplier agreement programs in place where they're ensuring that the products they're manufacturing for you are good, solid, safe products, have good maintenance programs in place and sanitation programs in place to ensure that we're removing the risk of foreign material in the production environment, and then have good inspection systems and understand their true capabilities during production to successfully run your production. I think eventually you can get yourself to a point to where you have a high level of confidence that that glass didn't come from your facility. And that's really what you should build for. Okay, thanks, Robert. Just a couple more while you're here. Antonio, we have items containing up to 30% by weight of salt and have difficulties adjusting the metal detector. Any idea how we can improve this? We have multiple rejects due to salt content in the product. Yeah, so I mean, metal detection is a very common topic, of course, and so we get a lot of questions in these areas. Historically, detectors were relatively simplistic devices that operated on a single operating frequency and had some limitations based on the product that was passing through there. You set up a threshold, and if the signal goes above the threshold, regardless of why, whether it's added salt or because of physical contamination, as long as that signal goes above the threshold, you get a detect event. So when you have variation in the product itself, that can react to a conductive variation in the product, which relates to a setup issue with the detector. So newer advancements in technology for metal detection are multi-simultaneous frequency detectors that, rather than operating at a single frequency at any given time, they're operating at multiple frequencies. And the detector runs those signals through various algorithms to help reduce the likelihood of things like false rejects due to product change. And I can give you an example. It was a pretty straightforward application, and one of the first applications that was done with the multi-simultaneous frequency technology, and it was running whole chickens that were marinated. So right after a needle injection of marinade, which was very inconsistent in its injection method, you set up a detector so a single bird went through there and it was fine. But every now and again throughout production, you get a little bit of a jam up. Here comes two birds and they make their way through the detector. That added product signal automatically created a false detect. Nothing wrong physically contaminating the birds, just the fact that there was more product signal driving the signal above the threshold. With the multi-simultaneous frequency, we were able to set the detector up so that it didn't matter if one bird went there, two birds went there, three birds went there. The signal didn't create a false detect, number one, because we're looking at every individual signal that passes through the system and making an adjustment within an allowed parameter through the algorithm, and at the same time maintaining the overall sensitivity capability. That's a little bit different than the single operating frequency detector, where I can allow that 30% by weight more salt go through there, but to do so I'm reducing the sensitivity, making it more difficult to see the metal spec that I'm wanting to see. So multi-simultaneous frequency detectors work really well. X-ray application doesn't care about the conductive nature of the product, so that would be another choice for an inspection on that sort of product where we have a large level of inconsistency that does affect the performance of, say, a metal detector. So I hope I answered that well enough.
Yes, you did. Thanks. Final one, I think, from Paul. Is reducing metal detector testing frequency to increase productivity, not a loophole in monitoring the production process?
Oh, I'm not really sure. The question, I look at the testing of the detector as some people view that as the monitoring. Some people view that as the verification activity. Again, you wouldn't want to put yourself in a position to where you're just not testing. Certainly at the beginning of a shift and at the end of the shift, those are definite times when we need to test the system. We need to understand, is it working correctly before I start production, and at the end of production, was it working correctly throughout the day? The time in between that you test and challenge the systems, that's really, again, up to you and based on a lot of times your capacity to quarantine products should there be an issue. So I don't know that reducing the testing creates any kind of loophole. I think what you should do is you should look very closely at your process, at the benefit and the value of potential reducing the testing frequency, as well as the risks of reducing that potential frequency. I think every facility is individual in their own process, even within the same manufacturing brand at different facility locations, different production lines, different people. Those requirements may be different from facility for facility. So look at your risks, look at the value and the benefits, and make informed decisions based on that sort of information and that data.
I suppose if you're testing for years and years every half an hour and everything's successful, it's just common sense to reduce your frequency, I guess.
Yeah, I mean, and I think that I've got facilities that I've been dealing with, for 20 years, and they still have the same testing regimen. And you ask them why, and it's the answer is, well, that's how we've always done it.
Exactly.
I don't think in today's world that's a good enough answer. We need to look at improving it,
Yeah, great way to end that, Robert. Thanks very much. Yes, Jimmy, top webinar. Thank you. Yeah, it was a top webinar. So thanks again, Robert, and we look forward to seeing you again later in the year on the Food Safety Fridays.
Absolutely. Thank you to you and your team for putting these on. I think it's a great value to the industry. Happy to help out any way we can, and enjoy our continued partnership as we move forward. Great.
Thanks, Robert. Have a great weekend.
Thank you.
Yeah, ladies and gents, that's Robert Rogers from Metler Toledo. World expert. There is no doubt, bar none, he is the expert on metal detection and then X-ray inspection as well, and lots of other things. Okay, ladies and gents, I have loaded your certificate in the sidebar. We will be following up with an email with the slide deck, the recording, and the certificate if you don't get it. So thanks very much. Register for the next one next week about Kim on it from NSF International. We're talking about food safety culture, meeting the requirements for food safety culture, in GFSI standards. So happy Friday. Enjoy the rest of your day if you're still working, and then it's weekend. Okay, so have a safe weekend, enjoy yourself, and come back refreshed, and we'll see you next week. Take care. Bye.